Hello and welcome. Today we're going to continue on the topic of moments, and we're going to look at specifically the law of moments and how to apply it to a question. So from our previous videos, we've now looked at moments and the law of moments, but just to revise us or help us revise a little bit, the objectives for this, and we've covered the first three. Firstly, to describe the moment of a force as a measure of its turning effect and give everyday examples. If you remember, we looked at the scissor, we looked at the wheelbarrow, and so forth. Secondly, to understand that increasing the force or distance from a pivot increases the moment of the force. And this you've done by that PHET simulation game that you played for an assignment. So that would have helped you to understand this. Okay, next, calculate a moment using the product of the force and the perpendicular distance from the pivot. We're going to look at that a little bit now, but for today what we're going to look at is how to apply the principle of moments to the balancing of a beam about a pivot, and how to apply it to the principle of moments to different situations. So firstly, just a few words that you're going to pick up in here. Some of them I've looked up the root meaning of the word. Some of them they don't always completely state it, but as we use it, you're going to see what it means. Firstly, the moment. A moment is not like a moment in time that we would use in English. A moment, the scientific or the physics definition, is the turning effect that a force has on an object. So if you turn the door handle, that is called a moment. The force times the distance at which you are applying the turning effect. Then torque, the root word is to twist. So torque is also another word describing moment. Sometimes we use moments. Other types of questions with cars, we speak about torque, but it's a very similar concept, the turning effect of a force. Then equilibrium. The root word there is to be equally balanced. So when something is in equilibrium, it's balanced. The word pivot means a point, and we're going to see that is the point on which we balance our beam. And then stability is when something is firm or steadfast. Now, let's see if we can remember what is the law of moments. So as you recall from last week, we say that the law of moments states that the anti-clockwise moments are equal to the clockwise moment. So here is where the word equal and equilibrium, so they are balanced. Okay, a moment, we said, is a force times the distance, okay, from the pivot. And we said the pivot is the point on which we balance, okay, and the clockwise and anti-clockwise here is a direction, and the direction is because a force is what we've learned previously, a vector quantity, so it has a size and a direction. Okay, so what does that mean in reality? If we've got a beam or a seesaw and we apply a force here, a downwards force, okay, the force times the distance, okay, so we need the distance from here to there. Let's say that's 2 meters, and that force is 5 Newton, okay. So the force, in order for this seesaw, this beam, to be balanced, remember, when we want it equal, we want it balanced, then we need the force times the distance, okay, must be equal to the anti-clockwise. So remember, it's going to make it twist either clockwise or anti-clockwise. So you put your pen there, you push it down, and you look at that motion anti-clockwise in the opposite direction of the motion of the clock, and therefore this side will be anti-clockwise. And if we have another force here, let's say 10 Newton at 1 meter, Now we can see that 5 times 2 gives me 10, and 1 times 10 gives me 10. And if these two values are equal, then it will be balanced. Okay, and that is the law of moments. Just a brief recap on what we did our video previously. So this is a typical question on the law of moments. And the key word that we're going to see here is that the ruler remains balanced. And that is the key word to tell us that since the ruler is balanced, we're using the law of moments. So to solve these questions, we want to ask ourselves, what are the steps to solve an equilibrium question? The first step would be to identify the forces and their directions. So if we look at this question, we see that there is a force of the apple on this side. There is a weight on the other side. Okay, we know that from our previous section that the pivot itself of the ruler itself also has a weight. But the moment we put the ruler or the pivot underneath the ruler, we cancel out this whole section here. Okay, so we don't worry about the weight of the ruler itself. We only consider the apple and we consider the weight on this side. So the first thing is we want to see and consider the forces. So here is a force, a weight downwards, and there is a force, a weight downwards. Secondly, we want to look at their directions. Okay, so if we look at this one, you can put your pen there on this from the pivot this way, and you will see that this apple is going to make the seesaw turn this way. So this is an anti-clockwise moment. I usually write anti-clockwise as ACW. And if we look at the weight on this side, it's going to move to the clockwise direction. Okay, so the fact that they've told me that this is balanced means that the anti-clockwise moment caused by the apple must be equal to the clockwise moment from the weight. So our next step would be to identify the distance from the pivot. Now this is a very, very important step because they love giving you the wrong distances. Do not always assume that the distances given is the ones that you should use. We need to use the distance from the pivot to that point. And in this question, fortunately, they gave it in such a way that the distances is measured from the pivot to the object. They could, for example, give you that distance saying that is 5 centimeters on the edge. But we can't use that 5 centimeters because a moment is the force times the distance to the pivot. Your next step will be to write the equation for the law of moments. So we know that our moment anti-clockwise must be equal to our moment clockwise. Okay? A moment consists of a force times a distance to the pivot on the one side, and that must be equal to a force times a distance to the other side. So we've written now our equation. So the next step would be to identify and to substitute into my equation. So we've already identified that the apple will be the clockwise, anti-clockwise, and the weight would be the clockwise. If we look at our question, they ask us to calculate the weight of the apple. So we have the distance from the apple to the pivot, which we're going to substitute on the left-hand side of the equation. We have the distance from the pivot to the weight, which we're going to substitute on the right-hand side of the equation, and we've got the weight itself. So this is the force of the apple, which we want to calculate. That is 25 centimeters. And on this side, we can leave our units out. Here we have 0.4 times 45, which is the distance in centimeters. So on this side, that equates to be 18. On this side, we've got F times 25. We want to calculate F, so we divide with the 25 on both sides. And that ends up that F is equal to 0.72. And remember, the unit is Newton. So you might be asking another question, what about converting? Law of moment is one of those questions or equations that is very, very, very easy to use because we don't need to convert. If we have a force on this side and we have a force on that side, the unit actually cancels. So here we've got centimeters and there we've got centimeters. And even though it's not meters, the effect of that unit is cancelled. So because there's the same quantity on both sides, we don't need to cancel. We can even substitute a mass in kilograms in here and a mass in kilograms in there if we want to solve an unknown distance. Just to understand what's the steps again, what is the law of moment? It says that the moment clockwise is equal to the moment anti-clockwise. The next step that we will look at is identify the forces. Why do we want to do that? Because the forces clockwise must times the distance must be equal to the forces anti-clockwise. So the force and the distance of the direction is very important. Next, we identify the distances from the pivot. Okay, we don't have to worry about converting if the same unit is used on both sides. And then we write our equation so that we can calculate our unknown. We substitute into the equation and then we solve the unknown value. I hope that makes a little bit of sense, and if we look if you go and try this questions now, I hope you would be able to understand. If not, please let me know. Thanks.